For that, in the components folder, I'll add a new subfolder. I'll name it demo. And in there, I'll add a new file, and that's my demo output.js file, where I import React from React. And then here I have the demo output, where I get props. And I export this as a default, of course, so that's a standard component. At least it is as soon as we return JSX. And now I'll take my paragraph here. This is new. Remove this line here from the app component and add it instead here as the return value. To be precise, I'll do something slightly different now. I will not conditionally render my own component or not, because it should be obvious that this will behave like rendering the built-in paragraph component or not. Instead of demo output, I'll change the HTML structure a tiny bit. It'll not just be this paragraph, like this. Instead, I will render this text in the paragraph conditionally. And I will render it conditionally based on some data I get through props. So that I can check if props show, for example. So if the show prop is truthy, let's say we expect a Boolean here, so if it is true. And if that is the case, then I want to render this is new. Otherwise, I will render an empty string. So the paragraph element is always rendered, just the text changes now, based on the show prop. So now back in app component, I therefore want to include my demo output here. So make sure you import demo output, of course. And there I want to set the show prop, because we use that show prop in demo output. And the value we pass here should, of course, be show paragraph, because that is a Boolean. It is false initially, and it's changed to true if we click the button, and then back to false, and so on. So now this component here is always rendered, and in the component the paragraph is always rendered, but the text that's shown, that will change based on the show prop. So now if I save that, let's go back. First of all, if I click this, you see we got basically the same behavior as before. There is no great difference. Now if we expand our DOM here a little bit, we see, of course, that the paragraph is always there. But again, if we click the button, we see that the paragraph flashes when I click it, and it flashes again if I click it again. Now, the reason for the paragraph flashing is that we now only work with that element, and we add or remove the text. And this is treated as a change for the entire element, which is why the paragraph flashes and not just the text. Because the text is basically like a prop to the paragraph, you could say. It's its content. But again, it's just a paragraph. It's not the h1 or the button element. So the fact that we're using a custom element, a custom component, does not change this. And of course it shouldn't. The updating mechanism should always work by comparing differences. It is, of course, interesting to see that we are changing state in the app component, and yet only the paragraph, which is part of another component, flashes. So this, of course, proves that the React updating and diffing mechanism works and finds out changes correctly. Now, one other thing is also interesting, though. If we go to the console, and I reload here, you see app running, and you see that, of course, runs whenever I click this button. Now, keep in mind, the actual change happens in demo output. But of course the app component runs again as well, because that's where we manage the state. And I mentioned the component where you manage state or where you have props or context and that state, props, or context changes, that component will be re-evaluated and re-executed. And we are managing the state in app. So just because the change visually only affects this paragraph in another component does not mean that the app component is not re-evaluated. Of course it is, because there we manage our state. And that's, by the way, also what I meant earlier with props and context, in the end always coming down to state changes. The props we got in demo output are of course responsible for why demo output is re-rendered. But ultimately, of course, the value we get here on the show prop is the value we manage in the show paragraph state. Ultimately, it all comes down to state and state changes in React. Now, it of course should be obvious that if I now add a console log here in demo output, that we'll see this being printed for every button click as well. We see it initially because that component is rendered initially. And then if I click toggle paragraph, well, we again see demo output running for every click. And again, that makes a lot of sense because the props changed with every click. So thus far, this hopefully all is pretty clear and pretty straightforward. Now I'll show you something that might be confusing. Keep in mind that demo output running is printed for every click, and again, that makes sense because we do change the state and therefore the props here with every click. But now let me tweak this. In app.js, I will now hard code the value I pass to show, and I will set this to false. This means that will never show the output because it's now detached from the show paragraph state. Indeed, I'm not using the show paragraph state at the moment. I'm still changing it, but I'm not using the state value. Now, what would you expect as a result? Let's see. If the app reloads, we see app running and demo output running. Makes sense, the app just loaded, both was rendered. But something interesting happens when I click toggle paragraph. If I do that, you see app running. Okay, we changed the state there. But you also see demo output running. And that's interesting. The props didn't change, right? We have the show prop, and the value I pass in there is still false. It never changes, it's always false. So why was demo output re-executed? Well, let's take it step by step. The app function is re-executed because state changed there. Now what is part of that app function? Of course, this return statement, and there we return some JSX code. Now all those JSX elements here in the end are like function calls to the respective component functions. So we call the function for the demo output component, we call the function for the button component. That's why those child components are also re-executed and re-evaluated just because the parent component changed, because they are part of the parent component's function body. And if the parent component function runs again, of course the child component functions also run again. So in the end, the prop value doesn't even matter here for this component to be executed again. It's just the fact that the parent changed. Changes in props might lead to actual changes on the real DOM, but for the function to be re-evaluated, it's enough that the parent component was re-evaluated. Of course, the fact that demo output runs again does not mean that the real DOM is touched. We can verify this with elements. There, you'll see that nothing flashes. I can hammer that button and nothing changes there. Because React just re-evaluates the components, and as you learned, re-evaluating a component and rerunning its component function is not the same as re-rendering the real DOM or manipulating the real DOM. But it is really important to understand that if a component is re-executed, all its child components will also be re-executed and re-evaluated. So therefore, of course, not just the demo output component is re-evaluated, the button is as well. If I console log button running here, you will see that if I go to console and reload, we see all three outputs initially. And if I click this toggle paragraph button, we also see all three. So the button component is also re-evaluated as well. This, of course, brings up one question though. Here we have a very simple app, just one root component with two child components, which then each don't have any more child components. If they would have child components, though, those child components would also be re-evaluated. Of course, and I can show this to you. If I add a my paragraph.js file here, where I essentially copy demo output, but I then simplify this, and here I have my paragraph also as a component name. And then in there, I just output a paragraph tag with props children in between. I can use my paragraph instead of the built-in paragraph, and I'm really just doing this for demo purposes here to show you how React updating works, not because this would be such a useful component. It isn't. But now with that, if I add my paragraph, which replaces the built-in paragraph, just to then reuse it. If I add this, you of course will see in the console that my paragraph running also is re-executed for every button click. So this continues down the component tree, and this brings up one important question. Isn't this bad? Because if all those component functions are re-executed, that's a lot of ongoing function executions and virtual comparisons that certainly cost some performance, right? So isn't this bad if there actually is no reason for that? Because we know, for example, that we never need to re-evaluate demo output because it can't change. The only prop which it has is hard-coded. If it had no props at all, we also would know the output in there will never change because of the state that's managed in app component. So re-executing demo output and all its children is a total waste. Well, this certainly costs some performance. Of course, we got ongoing function executions, we got a virtual comparison. It's needless to say that React is highly optimized for those executions and comparisons. So in a lot of apps, and especially in simple apps like this one, this will absolutely not matter. Nonetheless, in bigger apps you might want to optimize that, and therefore you as a developer can tell React that it should only re-execute this demo output component under certain circumstances. And those circumstances would be that the props which this component received changed, for example. So that if I bring back show false here, React actually checks if the show value changed, and only if that's the case, it will re-execute demo output. That might be closer to the behavior we want. How can we tell React that it should behave like this? Well, we have to go to the component for which we want to opt into that did the prop change check. And we simply wrap our component, for example, here in the export line, with React memo. This is for functional components. For class-based components, this does not work, but I'll take a closer look at class-based components and how to optimize those in the class-based component section later down in the course. Since we can basically work with only functional components, class-based components are not the focus here. So React Memo allows us to optimize functional components. Now, what does Memo do? It tells React that for this component, which it gets as an argument, React should look at the props this component gets and check the new value for all those props and compare it to the previous value those props got. And only if the value of a prop changed, the component should be re-executed and re-evaluated. And if the parent component changed, but the prop values for that component here did not change, component execution will be skipped. If we wrap this and we save that, we can see the result of that by going back. Initially, of course, demo output is executed because the app was just rendered for the first time. But now if I clear the console, if I click this button, you see only app and button running is being printed. The demo output running is not being printed. And therefore, my paragraph running is also not being printed because my paragraph is a child of demo output. And if demo output is not re-executed, of course, its child is also not re-executed. So this is now an optimization in place here that avoids this unnecessary re-rendering. Now, that might bring up a new question though. Why aren't we using that on all components if it allows us to optimize them? Because this optimization comes at a cost. The memo method here tells React that whenever the app component changed, it should go to this component here and compare the new prop values to the previous prop values. So therefore, React needs to do two things. It needs to store the previous prop values and it needs to make that comparison. And that, of course, also has its own performance cost. And it therefore greatly depends on the component you're applying this to, whether it's worth it or not. Because you're trading the performance cost of re-evaluating the component for the performance cost of comparing props. And it's impossible to say which cost is higher because it depends on the number of props you have and on the complexity of your component and the number of child components your component has. Of course, React Memo can be a great tool if you have a huge component tree with a lot of child components, and on a high level in the component tree, you can avoid unnecessary re-render cycles for the entire branch of the component tree. Like in this case, by avoiding the re-evaluation of demo output, we're also automatically avoiding the re-evaluation of my paragraph, even though we're not using React demo in there, just because we cut off this entire branch. So this entire branch of the component tree. That is something where React Memo can definitely be worth it. If you, on the other hand, have a component where you know it's going to change, or its props values are going to change with pretty much every re-evaluation of the parent component anyways, then React Memo doesn't make a lot of sense. Because if the result is that the component should re-render anyways, well, then you can also save that extra comparison of the prop values. That's then just some overhead cost, which is not worth it. And of course, ultimately, as always, it depends on your app size. For small apps, for small component trees, and so on, for all of that, it might simply not worth it to add this. But for larger apps, where you can cut off entire branches of unnecessary re-evaluations, it might very well be worth it. You just don't want to wrap every component with React Memo. Instead, you want to pick some key parts in your component tree, which allows you to cut off an entire branch of child components. That's way more effective than doing this on every child component. So now that we learned about React Memo, let's also apply it to the button. We can argue whether that's good or not, because the button is a trivial component, so doing that prop checking might not be worth it. On the other hand, we as a developer know that this button realistically doesn't really change. So re-evaluating the button all the time shouldn't be worth it. There's nothing on it that changes, right? We have the same text, we have the same function, so why don't we wrap it? For that, let's go to button and use React Memo down here and wrap our button component with it. Now you will see something interesting if you do that. If you save that and reload the app, of course initially we see button running, but now if I click toggle paragraph, we again see button running. Why is that happening? That makes no sense, right? Well, we see button running again and again because actually its prop values did change. That's strange, right? If we have a look at that, it only gets one prop on click, or actually two props, the children here, but both prop values never change. We always have the same text and we always have the same function, right? Well, this is one of the most common gotchas with React. Keep in mind that this app component is just a function in the end. And it re-executes like a normal JavaScript function, because it is a normal JavaScript function, if your state changes. The only magic thing here is that the function is going to be called by React and not by you. But then it still executes like a normal function, which means all that code executes again. And that has one important implication. Of course, this function which you pass to the button is recreated. This is now a brand new function for every render or every execution cycle of the app function, because in the end it's just a normal constant which we recreate. All that code in here is executed again, so of course a new function is created. This is not the same function all the time. It's a function that does the same thing, but technically to JavaScript it's a brand new function for every time the app function is being executed. That's, by the way, also true for false being passed to demo output. Previously I said that this never changes. Even that technically was not correct. This app function is re-executed, therefore a new false value is created. So even if we had false in the last render cycle too, now we have a new false. But if that's the case, why does React Memo then work on the demo output but not on the button? What's the difference between false and the function here? If a new false is created and a new function is created, shouldn't then both components be re-evaluated? Well, for that you have to keep in mind that false is a boolean, and booleans like strings and numbers are primitive values in JavaScript. Now what React Memo does in the end is it has a look at all the prop values, and in the end it compares props show to props previous.show, you could say. This is not exactly what it does internally, but you can imagine it like that. So in the end, it has a look at the previous value for the show prop and compares it to the current value. And it does so with a regular comparison operator. Now for primitive values, that will work. Because for primitive values, if I compare two booleans, I get true if they are the same. If I compare two strings, I get true if they are the same. Now technically, that is a different boolean than this here, and that's a different string than this. These are two different values. But for primitive values, this comparison works. Now that's not true if you compare arrays or objects or functions. For comparing two arrays, let's say, which look similar to us humans, in JavaScript, they are not equal. And that's not React specific, that is JavaScript. And attached to this lecture, you find an article and a video on primitive and reference values so that you really understand this, because that's a core concept of JavaScript. Now, it's important to understand that functions are just objects in JavaScript. Again, not React specific, that's just JavaScript. So here, a new function object is created with every time the app function runs. And this function object is passed to the onClick prop. Now therefore, button in the end compares props onClick to props previous.onClick, for example. And in there, we have two function objects. Now two objects, even if they have the same content, are never equal in JavaScript when compared like this. And therefore, React Memo finds out that the value changed just because of how JavaScript works. Now that is really important to understand. I know it's a common gotcha and something a lot of developers, even more experienced ones, are struggling with. That's why I'm emphasizing it like this. This is crucial to understand and to get right. Now, of course, as a result of that, does this mean that React Memo is useless for components that receive objects or arrays or functions through their props? No, thankfully not. Let's have a look at the solution in the next lecture.